Well, my name is Paul Murdin, and I first went to Husmansu as a student, and I spent effectively the whole of my working life working for the Royal Greenwich Observatory in one form or another, as a scientific researcher and then as an administrator. When I was an undergraduate doing my degree, which was physics and maths, one week, a few weeks before the summer term, there was a notice appeared on the college notice board saying that you could go to Husmansu and be a summer student. Mornings lectures, afternoons project work, and I thought that'd be a great thing to do, not least because they offered to give you an allowance and put you up free, and it was 8 weeks that I didn't have to support myself. And I little realised how interesting it would be. It blew my mind away when I was working on the project. I was measuring the positions of stars in a star cluster on a photographic plate, piece of glass with a picture of the star cluster on it, and I measured the positions and the brightness of these stars. Actually, what I did was I measured the positions by putting a cross on them, and I measured the diameter of the image of the star on the photograph, which is correlated with the brightness. So then I found out that from this you could measure the motions of the stars and the motion of the cluster around the galaxy and the brightness of the stars and how some of them varied, how far away the cluster was, how old it was. It just blew my mind that you could find out all of these fantastic things from spots in a picture. And at the end of that 6 or 8 week period, whatever it was, like all the other students, we were all called in one by one to the office of the Astronomer Royal.
Who was Richard Woolley at the time?
That was Richard Woolley, and so he sort of glared at you over the half-moon spectacles across the desk and asked you about what you'd done. And we talked a little bit about it, maybe 10 or 15 minutes. And at the end of that he said, "What are you going to do when you graduate?" And I said, "I don't know yet." And actually what was in my mind at the time was I might be a physics teacher, because those are the physicists that I knew were physics teachers, so I might be a physics teacher. And I might have mentioned that, and he said, "Oh, don't do that." He said, "Don't do that, come and work here." So it turned out that it was a job interview, really. I started work there in what was called the Observatory group, which is measuring the positions and the motions of stars. Again, it was very interesting, but it gradually began to dawn on me that I would forever be, as it were, a slave in a team of people that were carrying out this big scientific project. In the old days, I would have been called a computer. They said, "Well, once you get a PhD, why don't you go to the United States?" So I did. And I was there for 7 years, got a PhD, and then I returned back to the RGO at the end of that and stayed there until well into the 1990s. I came back as a fellow, which meant a 3-year temporary position to do the research that I wanted to do.
Which was?
And that was to investigate the stars that you can see in the sky in order to identify what had started to become found in great abundance, namely places in the sky where X-rays came from. It was a bit witchcraft, really, because you didn't know really what you're looking for. X-rays come from things that are hot, so maybe there would be signs in the spectrum that the hot gases around. X-rays come from places that are quite small. The idea is that there's gas that's compressed very strongly, so that's small, right? So it might be that these stars varied quickly, that their light flickered. And I started off first of all looking for flickers. And then I went on to look for hot gas in the spectrum of stars.
What telescopes were you using for that for?
Principally the 36-inch Yap telescope, which had an experimental spectrograph put on it, and then also the Isaac Newton telescope. I needed fairly big telescopes because the stars that I was studying were pretty faint. One of them was a star which I'd realised was within what was called the error box. The zone on the sky in which the X-ray sources are located is an error box. The position error, it makes a box on the sky, right?
Okay.
And there were numerous stars on the sky within that box. One of them had a catalogue number. It was HDE 226868. That's forever in my brain. Even when I'm completely gaga, I should be able to tell you the number of that star. So we looked at it with a spectrograph, and in fact there wasn't that much that was extraordinary about it. It was a B supergiant star. That was all it was. But it happened that I was working with Louise Webster in its same office as Louise Webster, and she was in charge of a test of an instrument that was being made for the Isaac Newton telescope, a new spectrograph. And one of the tests that had to be done on this spectrograph was to find out if you could get the same answer for the speed of a star over and over and over again. And if you didn't, then either there's something wrong with the spectrograph, in which case that it was her job to find out what, or the star was moving in some way. And so this star had the characteristics that suited the test. So we measured the radial velocity, the speed of the star over and over again. And I suppose we measured it about 3 or 4 times, and 3 or 4 times it came out exactly the same, and then one time it was different. And so this was either a problem with the instrument, and we didn't have much of a clue what kind of problem it was, because it was one discordant observation, or the star was interesting in some way. And so we went on, and after only a matter of a few weeks, it did appear that the star was moving. And so it was the explanation, the natural explanation for that, was that it was a star which was in orbit around another one. And we could see that star, but we couldn't see the other star. And so we measured the characteristics of this orbit, which told us the mass of the other star. And so here we were faced with a situation of a star which is ordinary, and another star we can't see, which might be ordinary, might not be. A place where there were X-rays coming from, possibly this unseen star, and we knew the mass of it. And the mass turned out to be 6 solar masses, 6 times the mass of the Sun or more. And that was interesting, because if you had a small star emitting X-rays of mass, 6 solar masses, what star could it be? It might be a white dwarf, might be a neutron star, but they have masses that are only about 1 solar mass. Or it might be bigger than that, it might be a black hole. They were a solution looking for a problem. Theoretically they could exist, but did nature make any? And that topic, that question, had started to become important because it was an explanation for these X-rays. Maybe, it was thought, you could have an ordinary star with a gassy atmosphere and then a black hole nearby, and the gassy atmosphere might leak onto the black hole, fall down the black hole, get squashed, get hot, emit X-rays. So people were just starting to talk about that kind of thing. So Louise and I published a paper about the X-ray source Cygnus X1, which might be identified with this system that contained HDE 226868, and if so, and it all connected together in this way that we'd fantasized about, then the companion was a black hole. And that transpired to be the case. There was a large amount of evidence that accumulated since to suggest that that was right.
Amazing.
So it was a good discovery. I mean, it was just very striking that the day we came to that conclusion. we had the data, we sat down to start to analyse it. Louise had some other meetings to go to. I went on analysing it. It was in one of the turret rooms in the castle, one of those octagonal rooms in the turrets. The one nearest the equatorial group, in fact.
Okay.
And then bingo, God, it must be a black hole. You know, have I done this right? You know, I'm going to go through the calculations again, go to the library and check I've got them, remember the formula properly, and so on and so on. So yeah, it was after about 1 hour. I mean, we several weeks of getting the observations, and then 1 hour of doing the analysis. I thought, crikey, this is a black hole.
That's been very exciting.
It was terrific. It was terrific. And of course, then we wrote up the paper, and there were some obvious things to do next. I mean, could you the orbit, the period of the orbit of the stars around each other was 5.5 days. So did the X-rays show any correlated behaviour? Were they changing on a period of 5.5 days? That would link them together quite neatly, and so on. So there was an obvious reason for publishing the paper and saying this, and we were able to tackle the speculation on might be a black hole. In fact, they were the last 2 words in the paper, as I remember it. We had the observatory was run in a quasi-military way in those days. It was Royal Naval establishment. When I first went, some of the staff had to line up in the morning at 7 o'clock and they had a mustering out parade, and there were anchors engraved on everything, and the banisters of some of the stairways were ropes with Turk's head knotting on the end. It was very naval.
Yeah.
And the whole thing was run as kind of a top-down sort of exercise, as you can imagine, even in science, in the fact that there were projects which were driven by the senior people. They were the officers, as it were, and we were the men. And so there was a lot of permission to be got before you could go outside with a paper which might be wrong and therefore might bring the observatory into disrepute. And there was a certain amount of resistance about us publishing a paper about a black hole, because in this staid Sussex countryside, black holes had a kind of a mystical overtone. They were a bit Californian, a bit New Agey, and maybe it was all daft.
So was the AR the stumbling block? Was he saying that should we really publish this?
The senior people were, that's right. And I don't think he ever understood it. I visited him in South Africa when he went to South Africa to direct the South African Astronomical Observatory, and I visited out there several times, and he'd retired, I think, at that time, and he took me to tea in a very nice quasi-English tea room near Cape Town, and I remember sitting with him in the sunshine under the jacaranda trees, and he leaned across the table at the end of the tea, and he said, "Now, Murdin," he said, "tell me again," he said, "what's the reason why you think that Cygnus X1 contains a black box?" So I don't think he ever really understood about black holes. They were black boxes to him.